So, 2.3, polynomial functions. All right, here we go. First couple of things. I need for you to be able to describe the end behavior. And so far with what we did so far, I think we're okay. Please note, we're using limit notation. Okay, that's the whole infinity stuff. All right? Okay. Be able to find the zeros of a polynomial by factoring. That's what we're going to talk about today. All we've done so far is this little bit. Okay, so something has a positive coefficient and an even power. The end behavior looks like this. If it has a positive coefficient and an odd power, it looks like that. Negative coefficient means the negative in front, and an even power, it looks like that. Odd power, negative coefficient, like that. Okay? Now, in the next couple of problems, they ask us to describe the end behavior using these limits, okay? All right, and they say the limit as x goes to infinity and the limit as x goes to negative infinity. Let's start with this one. Even or odd?
It's even.
It is an even positive coefficient. It looks like this. The limit as x goes to negative infinity and the limit as x goes to infinity. Both of these are going to infinity, okay? So if you want to put those in there, that might help. Both of these are going to negative infinity. This one's going to infinity, negative infinity. Okay? That's where the function going. That's the limit of the function, you guys. It's not where x is, but it's the limit of the function. This one, odd, negative. That is this one right here. So the limit as x goes to negative infinity, or to the left this way, is infinity. The limit as x goes to positive infinity, or this way. Do these pictures help a little as you're trying to describe them?
Yeah.
Okay. And if you can remember to maybe on a quiz or a test, sketch these real quick, these four. That'll help you a lot in your descriptions, okay? All right. I'm not going to do these C and D because I think, are we okay with this?
Yeah.
Okay.
On the test, would you mark us down if we didn't write like
Yes, I would like you to write, okay, so some people are saying maybe we could just do this. As x goes to negative infinity, y goes to... How many people would rather write it this way? That is fine. Okay? You can use the limit notation. This is what you're going to see if you're going to go on and take calculus, but this is just as fine.
Okay.
Okay? All right. Now, is that okay if I turn?
Yeah.
Okay. Oh, I'm sorry.
No, don't worry about it. Don't care.
I do. Okay. All right. Now this next one. Okay? Polynomial functions of higher degree. Here we go. Zeros of a polynomial function. Where are the zeros, you guys?
That were out of the x.
Okay. You guys, it says right here, the x-intercepts of a function are also called the zeros. Very important to keep in mind. Factoring allows us to find these zeros algebraically. A polynomial of degree n has at most n zeros. Okay, look at this right here. At most, how many zeros can this have? All right, so has, okay. If something, you guys, has at most 3 zeros,
That doesn't mean it has.
Hannah, what's the most number of times it can cross the x-axis? If it has at most 3 zeros, then 3 times, exactly. If it's an odd function, let's try to think about this for 1 second.
Wait.
If it's an odd function, what's the smallest number of times it can cross?
So, 2.
0, 1, 3 times.
It's an odd function. So that means that its end behavior, I'm going to flip back for a second, looks like this.
1.
It has to cross at least once. Do even functions have to cross?
No.
No, because this could be above the x-axis or below the x-axis. But odd ones have to cross at least once. Okay? So that's something to keep in mind about even and odd functions. All right.
Wait, so that doesn't mean it goes through 3 times. It just means
No,
at
that it
most
could.
can.
That's right. It could go through 3 times. We're going to find out right now how many times it goes through. We have to remember some Algebra 2 factoring rules. All right. So the first thing you do, number 1, set equal to 0. We're trying to find the zeros, so we set the function equal to 0. Number 2, factor. What can I take out of x cubed and x? Or 16x and x?
Tommy Anderson to the main office.
Okay.
Tommy Anderson.
All right. So we're going to take the x out, and we are left with x squared minus 4 or 16. Now, take a look at this right here. This is the difference of what? Perfect.
Perfect square.
So how can this be broken up?
X plus 4, x minus 4.
All right, x plus 4, x minus 4.
Definitely got it right.
Now, take a look at each one of the factors. Do you agree that if x equaled 0, all of this would equal 0? What could I put in here to make x equal 0? What could I put in here to...
Negative
-4.
four.
What could I put in there?
4.
4.
All right, so the zeros of this function are x equals 0, -4, and 4. Does everybody see that?
Yeah.
After you factor, you look inside and ask yourself what is going to be it. That's the zeros. If I took my calculator then, and I entered this function in, which was x cubed minus 16x, and I graphed it, you would see that sure enough, it's a cubic. It went up, down. Can't really see it too well. Maybe if I don't want to zoom out. Let's just change the window just a little.
You can't see it too well. It's right there.
I just want to see the curves of it so that you can see that it's, well, you can't again, but it's a cubic, okay? And you can see that it crosses at -4, 0, and 4. If you can't tell from the table, how could I find that 0? What would I do?
You would click 0, second calc.
There you go, yep. Second calc, 0. And you would go to the
Left,
left of it, to the right of it, and you would get, there it is, there's 1, 0, -4. All right, and you would do that if for some reason it was in between and you couldn't tell. Okay?
Okay.
All right, next one. 3x squared. All right. It's a squared, it's an even. What is the most number of times this is going to cross?
Only 2.
Twice. It could touch for 1, it could be 0. Now, How do you factor this one? First, set it equal to 0. Okay, now we have to do the AC method. What does A equals 3, B equals 1, and C equals -4?
4 and 3.
Yep, what does A times C equal? Okay, and that has to add up to B, which is 1. So, this is how it works again. Two things. When you multiply them, you get -12, and when you add those same two numbers, you get 1.
Oh, yeah.
What two numbers multiply to make -12?
Oh, -4 and 3.
-4 and 3.
Oh,
But
3 and -4.
-4 plus 3 equals a -1. So it must be 4 and -3. When I multiply them, I get -12, and when I add them, I get 1.
Yeah, now it's ready. So then how do you write that out?
All right, nope, we're going to do this. Draw yourself a box. Leading term goes right here, 3x squared. Last term goes right there. These two, when you add them, they have to equal a positive x. So this must be a 4x and a -3x. Can I tell you right now, Kayla and everyone else, it does not matter which box you put them in. You could put the 4x here and the -3x there. That's okay.
Could you put the 3x squared to the right?
Yes, these two have to go here. The leading term has to go in the first box, and the last term has to go here. Then what you do is we want to factor. So you look at these two bottom terms. What can I factor out of the two of them? Do they have anything in common?
-1.
-1. So you put a -1 on the outside, okay? Right here. What about these two? Just an x. Going up, what do these two have in common? A 3 and an x.
The x is independent.
Yes. No, you're right. And what about these two? What do they have in common?
4.
All right. So these things on the outside, those are my factors.
Holy.
Yep, 3x plus 4 and x minus 1.
Wow.
There you go.
Have you
Now,
done that before?
I have not showed you this box because the box is a little handier. Now, ask yourselves, what are my zeros of this? X equals what? 1. And what is this one over here?
-4.
-4 thirds.
What?
It's always this divided by that.
All right.
Is it? Wow. Okay. Okay. Do you want me to do, you guys, would you like me to go through one more so you have a reference for your homework?
Yeah, we might just as well.
Okay. All right.
Do it really quick.
First things.
Take your time, we got 2 minutes left.
No, I thought we had 5. Okay. First things first. Before you go and factor, what is common to all three of them? What can I, a 2 and an,
X.
all right, so factor out a 2x. I'm left with 2x squared minus 7x plus 3. Guess what we get to do now?
What do we get to do now?
AC.
Oh.
A equals 2, B equals -7, C equals 3. All right, what does AC equal?
6.
Okay. What does B equal?
-7.
All right. So two things that when you multiply them, you get a +6, and when you subtract them, or when you add them, you get a -7. -6 and -1.
I was going to say that.
Okay.
Because -6 plus -1 is -7.
And when you multiply them, you get that +6 that we want.
+6.
All right. What goes in the top corner of the box?
Well, the first term.
Which is 2x squared. What goes in the bottom?
7
3. What goes in the kitty corners?
Whatever you want. Whichever
These
one.
two, doesn't matter. Negative 6x and just negative 1x. Okay. Now you ask yourself,
Negative x.
no, what about, no, this way. Negative 1. What about these two? What do they have in common?
An x.
Oh, yeah, the little
And a
2x.
2. What about going this way? Up?
Cloud, the 1x.
An x.
What about this way?
Oh.
A 2. Or 3.
Negative 3.
But that's
How do you-
positive 3.
Right.
How does that work?
How exactly? How do I know when to make it negative, when to make it
You make
positive?
it negative when the negative is.
Closest to the edge. Right here. This is negative because as I'm coming out, this one's negative. 'Cause that's, okay, look over here. These two right here, one was negative, one was positive, but because this is positive, you write the positive 4. Going this way, a negative 1, because that's what the negative is closest to the edge. Now, what are my 2 factors now? What do I write down over there? 2x, and then what are my next 2 factors?
2x, and then 2x minus 1, and then x minus 3.
Okay, so my zeros are x equals 0. This means x equals 0 from that one, guys. This is a positive 3, right, from there? What about this one? Yep. It's always opposite what you have for the sign, and it's always this over that. Okay? All right. Now, okay, what we're going to do, this is part of your homework right here. I am going to, this is just using your calculator, okay, to find the zeros. We are going to have to finish the notes on this tomorrow or the next day, okay? So we'll finish this up later. But your homework for tonight,
Just this packet?
Just this packet.
no, we'll do that later. But your homework that I'd like you to kind of get started on so that you don't have too much to do is